Welcome to probability session 9. We were doing some problems in exercise 27C. We'll continue that. Problem 27 says 3 coins are tossed together. When we toss 3 coins, first let us write the number of probable outcomes. 2 power 3, that is 8. So my denominator is always going to be 8. Let's remember this. The question says find the probability of getting exactly 2 heads. We have done this before. You can see that these are the 8 options that we have. So what is the probability of exactly 2 heads? Exactly 2 heads. So this is 1, this is 1, this is 1, this is 1. That's all. These are the 3 conditions which are satisfying exactly 2 heads. So P of 2 heads equal to 3 upon 8. The next question asked is, what is the probability of all tails? T, T, T. It's obviously 1 upon 8. And the third question, what is the probability of at least one tail? At least one tail. At least means it should have at least one tail. So we can see that other than this first option, everything satisfies. So it is 7 upon 8. Let's do problem number 29. Cards marked with numbers 1, cards marked with numbers 1, 2, 3, etc. up to 20 are well shuffled and a card is drawn. So how many outputs? I can clearly say that denominator is going to be 20. Total outcomes. What is the probability that the number on the card is a prime number? P of getting a prime number. Okay. Now we know that when we write these numbers, I have this 20 numbers written down here. So prime numbers would be 1. The prime numbers would be 1, 2, 3, 4, 5, 6, 7 and 8. So the probability is 8 upon 20 or 2 upon 5. Okay. The next question is, what is the probability that it's a perfect square? Probability that it's a perfect square. So how many numbers do we have satisfying this condition of a perfect square? We have 1, 2, 3 and 4. So the condition that the probability is a perfect square is 4 upon 20 or 1 upon 5. Okay. Then the last question is, what is the probability that the number which we take, let us say n, is divisible by 3? N is divisible by 3. So how many numbers do we have favorable outcomes here? Let us choose the favorable outcomes here. 1 is 3. 1, 2, 3, 4, 5 and 6. So we have 6 favorable outcomes. So the probability is 6 upon 20 or 3 upon 10. Next we do the problem number 31. From a pack of 52 playing cards, I have a pack of 52 playing cards. I have a pack of 52 playing cards. All cards whose numbers are multiples of 3 are removed. Cards whose numbers are multiple of 3 are removed. So we need to know how many cards are left. How many cards are left? So there are totally 4 signs. One is the hearts, diamond, clubs and spades. So in each sign I have number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After this we have the face cards, right? So multiples of 3 means I am removing this 3, 6, 9. So I am taking out 3 cards from each, right? So totally how many cards am I removing? I am removing 12 cards. So I am left with 52 minus 12 is 40 cards. Okay, this is the most important part. What is the probability that the card drawn is a face card? The first question is probability of getting a face card. Now I know my denominator is going to be 40 because I've already removed 12 cards. Of these 40, how many face cards? I'll get 3 face cards, Jack, Queen, King of this, 3 here, 3 here and 3 here. So totally I can say that 12 are favorable outcomes out of 40. So the probability is 3 upon 10. Now come to the second part. An even numbered red card. Even numbered red card. Please understand the question properly. Probability that I will get an even red card. Now, how many red cards are there? There are, you can say that this is one red and this is another red, either hearts or a diamond. So, I have even numbers means you can see that 2, this is one even number, 1, 2, 3, 4, 5. I have 5 even numbers of this and 5 even numbers of this. But out of this I have already removed 6. Right? I have removed this because it was a multiple of 3. So how many do I have? I have, the new condition is I have 1, I have 2, I have 3 and I have 4. So totally I have 4 in this and 4 in this. So I am left with 8 upon 40. So it is again 2 upon 10, that is 1 upon 5.